Hello and welcome to Vaslav's maths tutorial. I'm going to do a question from C1 exam in June 2012. That's question 8. The question asks you to present this quadratic function into a completing square formation. I've got here a formula which converts any quadratic equation into a completing a square formation here. Okay, so let's apply the formula on this given equation. That's the given equation. Let's first write it in the form of ax squared plus bx plus c formation, that is minus x squared plus 4x minus 5, and then I can take out the minus, and then I would have x squared minus 4x plus 5, like that. And then I'm going to apply the formula. Okay, so the formula says that's open bracket x plus b, which is minus 4. Remember, that's b, divided by a, 2a, which is 2, because a is 1, all squared. Then minus, same thing again, b, which is minus 4, divided by 2a, which is 2, all squared. And then plus c, which is in this case is plus 5. Okay, it's going to look a lot better once you simplify that. So it's going to be x minus 2, because you got minus 4 divided by 2, that gives you minus 2 squared, minus, same thing here, so you would have minus 2 all squared plus 5. Okay, further we can simplify this to x minus 2, yeah, sorry, missed out the minus, yeah, minus, so this whole thing here, it's minus 4 add plus 5, that gives you plus 1, so that becomes a lot more modified like this. Then effect the minus inside, we get minus x minus 2 minus 1, and get rid of the square bracket. Now it's beginning to look like the requested form. Remember the requested form, they wanted us to present it in terms of, let's go back, q. Okay, so they wanted us to present it in terms of q minus x plus p all squared. Okay, so we need to write down the constant bit first. So we rewrite our completing square form by writing minus 1 minus x minus 2 all squared, and make it identical to the given or the requested form. Now from this we can see that q relates to that, so therefore q is simply equal to minus 1, and this one here relates to p, so therefore we can say that p it's equal to 2, and that's part A. Okay, so let's go and do part B. Part B is asking us to calculate the discriminant of the same quadratic. So that's part B, discriminant of the same quadratic equation, minus x squared plus 4x minus 5. Remember, the discriminants are given from the formula. The discriminant of that is equal to b squared minus 4ac. So let's implement that. B squared, b is 4, so 4 squared, that's your b squared, minus 4, a is minus 1 here, and c is minus 5, and simplify that, you get 16 minus 4 times 5, 20, so the answer is minus 4. So that's the discriminant. That's part B. Part C, you've been asked to sketch the graph of the function y is equal to minus x squared plus 4x minus 5. Well, we can use part A, the form in which the completing square form we worked out in part A, to sketch the graph, because that's one of the advantages of presenting a quadratic in a completing a square formation. It enables us to sketch the graph very quickly. Okay, if we recall, that was the same as minus x minus 2 all squared minus 1. Okay, so I'm just going to write this again here. Y is equal to minus x minus 2 all squared minus 1. Okay, the quadratic function, either they have a minimum or the maximum. In this case, the coefficient is minus, so this graph would have a maximum value, and that maximum value, as you can see, is minus 1. So the maximum value is minus 1 and occurs at when this expression here is equal to 0. So when x minus 2 is equal to 0, that gives us x is equal to 2, we would have a maximum value of minus 1. So therefore the coordinate of the maximum value would be at 2 and minus 1. So next is to sketch the graph, because we got the important information. Okay, we know the turning point of the graph, so that would enable us to sketch the graph very quickly. So if this is my y and this is my x, the graph is going to have a turning point at 2 for x. Remember, that's also the line of symmetry for the quadratic. So that would be 2 and the minus 1. I'm going to do that here. So that must be the turning point. Let's stretch this one. So that's going to be the graph of my quadratic. Remember, you must present the coordinate of the turning point clearly on your diagram. So you need to stick that in here. So that's going to be at 2 and minus 1, and the y-intercept is equal to minus 5, because when x is equal to 0, y becomes equal to minus 5. Okay, so that should give you full mark. Thank you.